Okay, this video is going to talk to you about one different type of enzyme. So in this part of the study design, you need to know 3 different types of enzymes. You need to know the restriction endonucleases or restriction enzymes. You need to know ligases, which is another video, and DNA polymerase. So there are 3 different types of enzymes. So I'm going to talk about the first one in this video, which is restriction endonucleases, and the production of what we call sticky ends and blunt ends. So this is the rest of page 2 we should be filling in now. So to begin with, let's look at restriction endonucleases and what that means. So as I said, the 3 that you need to know are the restriction endonucleases, the ligase, and the polymerase. So why are they called restriction endonuclease? This means endo means inside, restriction means to cut. So cutting inside the nucleic enzyme is the A's bit. So cutting inside nucleic acid enzyme. Essentially, these are just enzymes that recognize, and this is what you need to know, DNA, they cut the DNA at specific base sequences. Okay, so they will go along and their active site is complementary to a specific DNA base sequence. So the active site, because these are enzymes, so they have active sites, is complementary to a specific DNA base sequence. Okay, and sometimes we don't call them endonucleases. You can also call them a restriction enzyme. There is no difference. You won't get penalized for using one or the other. Let's now jump to the next bit. We're going to come back to ligases in a really quick other video, just so that you can revise both of them independently if you want. So there are 2 types of cut that you can make with a restriction enzyme. You can either make this kind of stepped cut like this. Yeah, here's another example. And what it does is they leave, so here's your 2 pieces of DNA. So you've got one strand here, the other strand down the bottom here. So if you cut them with here we go. If you cut them with a sticky end, what you end up with is this kind of overhanging bit here and this overhanging bit here. So that's what a sticky end is. It's when it cuts at that kind of angle. So it'll go down between one base on one side. Hang on. It'll go down between the G and the A over here, and then it kind of cuts along here, in between here, and then it cuts down like that. And what you end up with are these 2 ends, and this is where I'm going to have to, sorry guys, rip this apart and have a draw for you. So what you would end up with in this case is you're going to end up with G, C, T, T, A as one end, and then as your other end, you're going to end up with A, T, T, C, G. So this is one piece of DNA, and then this is another piece of DNA. And you should be able to draw that. You don't have to remember all of these sequences, but if they told you what the recognition sequence is, you should be able to draw the product. So again, with this one, we're going to do this little section up here in green. So that sticky end, once it's cut, is going to be like this. A, G, C, T. And then this second bit over here is going to end up looking like this. T, C, G, A, G, and then a C on top. So you can see that they have this kind of jagged end. Now this is really, really helpful when we talk about why they're needed, which I'll get to in just a little bit. So the other type of cuts that you can make is a blunt end. So literally they just cut the DNA straight down the middle in between 2 bases. So in this case, this side, I know I'm jumping around, is going to look like this. That's going to be on the end of the DNA, and then there's more DNA over here. Whereas this side over here is going to end up looking like this. Now I want you to think about why that's important or what the benefit or disadvantage of using each one of these enzymes is. So I'm just going to show you a few more examples of different types of sticky ends and blunt ends. So these two up here, you can see that they're cutting straight through the middle. So these two are making blunt ends. Yeah, so you should be able to recognize, based on a recognition sequence, whether or not you're going to end up with blunt ends or sticky ends. Then these ones down the bottom here, BAM H1, hind 3 cuts like this, and Eco R1 cuts like that. So each one of them, because they're cutting in this kind of steeped fashion, these ones here will produce sticky ends. Now, and the last little picture I'm going to show you, because this one gives you a really good idea of what we're looking at here, is hind 3, again up the top. You don't need to know about this 5' and this 3' or whatever. All you need to know is whether or not it's going to make sticky ends or blunt ends based on where it's cutting, and they have to give you this. Yeah, they have to give you this information over here. You are not expected to remember all of the recognition sequences. I wouldn't know them, so therefore there is no chance that you guys will need to know what they are off by heart. So here's your hind 3 digest, and these are your 2 sticky ends produced. 2 sticky ends produced. That's in this one here. Now the next one, the PST1, that produces 2 sticky ends again. And then the final one is the Eco RV or Eco R5, whichever one you want to say. That one over here produces 2 blunt ends. So why would we want these 2 different types? Now, there's a distinct benefit in some respects when you use a sticky end versus a blunt end, but if you don't require the specificity, the blunt end works really well. So this is the last table on page 2. It says sticky ends. Essentially, we cut the DNA to leave those overhanging bases. And this means, and this is where you go, what's the importance of making sticky ends? It's this. Only complementary sequences, which means that you get very specific sequences of DNA can be joined, which means that you get very specific. Yes, you can choose which pieces of DNA in a way, because we can't do this under a microscope. We have to just kind of mix everything together in a jar or in a little tube and hope that it's going to work. But these sticky ends mean that only complementary sequences will join. With a blunt end, because the DNA is cut straight down the middle, it means that you can join together any 2. So I'm jumping back here to show you. So it means that if you cut down here and had this one, and if you cut down here, these 2 pieces of DNA could join together. Yeah, I'm just going to clear off my pen markings. So if you cut down here and cut down here, you could get this piece of DNA and this piece of DNA. They could join. However, if you cut down here and you have this sticky end here, and you cut down here and you have this sticky end here, these 2 sticky ends, although they have the same shape, they each have 4 bases overhanging. The 2 sticky ends from different enzymes can't join together. Okay, so that is the biggest benefit between a sticky end and a blunt end. And that's the end on restriction enzymes.